This says we're live, everybody. Welcome to Astronomy on the Spectrum. I'm David Reitzel, and with me tonight is Jameeka Marshall and Jared Head. Jameeka Marshall is program manager for Shadow the Scientists, and Jared Head, a colleague of mine, of course, at our other show we do, All Space Considered. But Jared, I don't know if you know, but he's also aerospace engineer, rocket scientist, space communicator, science communicator, educator, NASA ambassador at times. I don't know how many hats you can wear, Jared, but you got a good one on tonight with your
Well,
NASA
I was
hat.
about to say one for now. So
Yeah, one for now. But anyway, I anytime I need to have somebody on the show to talk about something that's happened in space, I always think of you. One, you're a heck of a lot of fun to talk to, and you always surprise me with the information you bring and the knowledge you bring. And it's just fun. So, folks, welcome to the show tonight. It's going to be a little bit more of a free flow chat show. I just drove back from my hometown of Reno, where I grew up. In fact, I should be looking at the camera rather than around on my desk here. Um, yeah, I just drove back from the town I grew up in Reno, where I was up visiting my parents. So, hi, Mom. Happy birthday. I was up there for her birthday and drove back the beautiful 395, the Eastern Sierras. And you go right
Mm.
past some radio telescopes on the way there. The
Ah.
Owens Valley has radio telescopes there. And if you're driving up and down there, you'll notice there's not a lot of radio signals there. It's not a true dead zone like it should be, in my opinion, but you're not you aren't going to pick up a lot on the radio. There's a lot of dead space on the radio, and hopefully they protect it that way. Those telescopes, you'll notice they're pointed different directions during the day. Well, as you can observe radio waves during the day, it goes right, you don't need to worry about it. If you're pointed close to the sun, you'll pick up the sun. It gives off radio waves. So it's pretty cool. One of these days I'm going to drive by. I'll make some arrangements so I can go there and maybe get a tour, take some footage of it, and that'd be a lot of fun. Jared, maybe you can come along. Jameeka, maybe you can come into town and meet us too. So that would be awesome. But anyway, so tonight, if I ramble, that's all that's going on. Is my brain is still a little bit on vacation, but I'm so excited tonight to talk about a few things. First of all, let me share my screen here, and there was this was crazy. Share sound and optimize for video sharing. This is a Blue Origin rocket here, and that's the New Glenn. And this is at Cape Canaveral. I think most of you probably saw this. So I'm going to start the footage, and they were fueling it, and then going to do a test. And that's not good. That's
mm-mm.
that's what I call suboptimal.
That's not desirable,
Yeah,
to say the least.
yeah, that's really not what you want to
Wow.
have happen. I'm going to rerun that and stop at a couple of points here, just so. So what were they doing, Jared? This was a test of the engines. Had they made any changes? Because this is a rocket that's flown before.
Yeah. So what they were doing was what's called a static fire. So in essence, they had their New Glenn rocket on the launch pad. In this case, Launch Complex 36, which is the one that Blue Origin leases at Cape Canaveral. Uh, the vehicle was on the pad doing a static fire, so that means they're going to fully fuel the rocket and then they're going to ignite the engines for a specific duration. They're
Hmm.
looking to grab data about those engines, see how they're doing,
Mm.
see how the systems are doing, the plumbing, the electricals, the avionics, other things like that. Just basically making sure that your rocket is supposed to work like you're expecting it to before you actually do the mission. And, this was something that,
This looks. I like this because it looks like a sunrise on a beautiful beach in
I
Hawaii.
thought it
yeah,
was a
Perhaps Jamaica,
sunrise.
where you are.
yeah,
Yes.
it's pretty incredible. The footage of this. Um, for what we know, this is the largest rocket that's ever exploded in the United States,
Oh,
by far. So this is somewhere on
Wow.
the order of about 1,300 tons of
Oh.
propellant exploding all at once.
now
Uh,
what
it,
kind of
it,
what kind of propellant? There's the boom, everybody.
yeah.
What kind of propellant
Wow.
was loaded on it? I believe this rocket has two kinds in the different stages. Am I correct on that?
Oh.
You see, so yeah, two different kinds. It's going to be using liquid oxygen as the oxidizer, and then the fuel is actually going to be methane.
Okay.
So it's what we call methylox. So it's using methane and liquid oxygen together and combining them in order to generate combustion, or at least in this case, accidentally generate combustion.
Yeah.
So,
Now,
um,
had they fueled the second stage? Because that one I think is hydrogen. But they
so I think it's a fully methylox rocket.
Is
I
it? Okay,
think,
then maybe the
yeah,
people I watched were wrong on that because I saw other commenters on it talking, hypothesizing what might be exploding in there. But I didn't see sort of the color of hydrogen burning in there, honestly. But I doubt they would have fueled up the second stage. But I don't know. I have no idea. I'm gonna have to look into that. But what I wanted to ask you about is in here, it looks like we can see a shock wave,
yes.
right? Soon after it explodes, right there was like a
Yes,
fast moving thing that went upwards. Are
I
we
saw that.
seeing the shockwave, Jared?
Yes, you are seeing the shockwave from that. So obviously the air in Florida is extremely humid, so you're going to be able to compress that air and pull the water vapor out of it into the shockwave. So yes, so you are seeing a supersonic shockwave coming off of it. So it is a detonation.
Wow.
At that point. I do want to point out, I did double check it just because I wasn't entirely sure, and I was like making sure to be right, especially
Yeah.
on the internet. So you are correct. It is a
Well,
methalox
but
first stage, and then the second
okay.
stage is liquid oxygen and liquid hydrogen, what we would call hydrolox. So it is two different fuels
Okay,
involved.
but
Yeah,
the question still remains, would they have bothered to fuel the second stage if they're just testing the first stage engines?
so
Just
that I
to
don't know.
I don't
It
know.
it does look like there is a distinct, almost like zippering up top on the rocket. So if you watch the
Right
explosion,
there. Yeah.
yeah, you could see it, and it's almost where the umbilicals or the hose systems that would attach to the second stage from the system that's actually attached to the rocket would be at. And it very much looks like whatever happens on the upper portion of the rocket ends up unzipping the rocket below it. And because of that, the entire fuel and oxidizer tanks
Mm.
are blown open. And then once you get that point with enough spark, you know, what can I say other than kaboom?
Yeah. Yeah.
So yeah,
Now you had said this was the largest US explosion. I know the Russians
yes.
have lost some big ones. It was at the N1 that was bigger?
Yeah, so it was the Soviet moon rocket, the N1. It was 1,000 tons more in terms of propellant load than New Glenn is. So New Glenn is about 1,300 tons of propellant, and then the Soviet N1 was just a little under 2,300 tons of propellant on the load on the launch pad. So the Soviet N1, the several of them that exploded in flight, because it just did not have a successful flight ever. Um, those are some of the largest man-made explosions, largest non-nuclear man-made explosions in history. So,
Wow.
and just to kind of provide a little bit of context for this, I have a earthquake app, and I just check it every once in a while just to like see what's been going on, because like if I wasn't into rocket science, seismology would be my other science I would be working in, and I saw that there was an earthquake in Florida, and I was like, "That's really weird. Like, that's like I got to see what this is." So tapped on it, and lo and behold, it was labeled Blue Origin New Glenn Rocket Explosion.
Wow.
So the USGS seismographs picked it up at a registering a magnitude 2.5 on I believe the moment Mercalli scale, which is what's used nowadays. Now, that does not mean that it let go of a equivalent amount of energy of a 2.5 earthquake. That is still way more energy as an earthquake at magnitude 2.5 than a new Glenn exploding on the launch pad. It's just that the amount of movement that occurred from the local seismographs in that area in the equivalent sort of what USGS would be able to pick up and automatic tracking and things like that, labeled 2.5 on there with it. But it was still
Right.
it was still labeled, it was still big enough that it was a seismic event that could be
Yeah.
detected by seismographs. So, yeah. It was a big boom. Like there's real
It was
no way to get around it. It was a big boom.
Big
So
yeah. Now
boom.
what does this do to our moon plans? Because I know that
uh,
this was a rocket that was involved with getting us back to the surface of the moon. They were talking about building a moon
yes.
base, this like a launch happening before the end of this year to start doing that moon base. Or is
Oh,
that all
wow.
off like gone now? Is that impossible?
It's definitely going to be incredibly difficult to make the schedules that occurred. As far as I know, it's been almost a week since the anomaly that Blue Origin had with New Glenn on the launch pad, and there's been no, at least public acknowledgement yet as to what's occurred. And I mean, that's not unusual. Like usually, you're not going to typically find out until about 6 to 8 weeks after an anomaly as to what occurred. Um, but it is very badly timed. Blue Origin had just publicly picked up a contract from NASA to start doing work on the NASA moon base, which, by the way, moon base is what NASA's calling it. I don't have anything inventive, I guess, for it yet. They're just calling it moon base. So this new moon base program, Blue Origin was going to be a anchor in getting the supplies to the moon, getting the hardware to the moon. And yeah, the rocket just blew up. And the hard part about this too was that on flight 3 of New Glenn, which occurred earlier this year, they had a anomaly with their upper stage engine after it reached its parking orbit, and it had a payload, a communication satellite payload it was going to deploy into a medium Earth orbit, and the engine didn't relight. And that's a really big problem because you basically have to go off of your data as it comes down to diagnose what the issue was. And that doesn't mean that something upstream from the data could have been the cause of the issue, and you're only getting to see what the anomaly was in the downstream. So it's the upper stage issues with rockets are really tricky because of how complex the upper stage of a rocket is. This is a
Yeah.
vehicle that has to operate in an environment that is very difficult to simulate here on the Earth. Not impossible, but you're putting it in a hard vacuum, hard radiation, other things like that, and it makes it tricky to figure out upper stage problems. And they had just finally gotten cleared by the FAA to, basically saying like, "Hey, okay, we've gotten your anomaly report. We accept it. You're now cleared to fly again." And then, 2 days before the explosion on the pad, they get the official contract from NASA to do this, and then 48 hours later, kablooey! It just
Yeah.
explodes, and their launch pad is damaged. So no way to get around that, right? It's the fastest way to build a new launch pad, I guess, or at least your fastest method for demolition to build a new launch pad.
Is
So they're probably going to have to go through a lot of everything and rebuild that. Ground support equipment, GSE, is just as complex as rockets are, just as expensive as rockets are, just as long to develop at times as rockets are. So essentially, worst case scenario has occurred in terms of keeping the Artemis program and the new moon base program on track. This was not what was. This is about as bad an outcome as you could possibly want. So I would say at least a year delay on everything, including the Artemis, like Artemis 3, Artemis 4. Right now, the industry is basically thinking at least a 12-month delay on what was already an ambitious and probably, I don't want to necessarily say naive, but definitely like we're pushing this just because we want to make sure that we look good kind of timeline that Artemis 3 and Artemis 4 were going to be flying on anyhow. So,
yeah.
um, and then another big component of the SpaceX's Starship, it had its first version 3 test flight just a couple weeks ago. There were some issues with it. It didn't quite ace it. There were still some problems with engines and a new technique as well to have the booster turn while it would separate from the Starship upper stage. It seemed to have overdid it a bit, and then caused fuel in the tanks to slosh around, which means that when it opened up the plumbing, there was nothing there. And if you have a rocket engine, suck nothing, a vacuum into it, it destroys your turbo pumps faster than the blink of an eye. So yeah, it was bad on that front with that too. So both of the providers of the Artemis program, in terms of landers and payload delivery and things like that, are having their own issues, and it's just like this ain't not great at the moment, unfortunately.
Yeah.
And this is what happens very early on in rocket programs. So it's better to catch it now than when you're supposed to be in program in flight. So catch it on the ground, not in flight. But at the same time, this was, at least in losing a launch pad for Blue Origin, it's pretty catastrophic.
Yeah, that's really bad. But I've noticed a difference in the way that NASA, SpaceX, and Blue Origin and SpaceX tend to be doing things slightly riskier. I would put
Oh
SpaceX at the
yeah.
most risky, Blue Origin a little bit more closer towards the NASA model of things
Hmm.
they seem to want to test on the ground a little bit more, although they're having, anyway, explosive, destruction. But SpaceX was blowing up rocket after rocket after rocket. That
Oh
was just
yeah.
what they're doing. So in a way, I'm not surprised. I was more surprised at the timetable they had put forward. I thought something like this wasn't inevitable, but it was highly likely. And I thought, to have a timetable that you can't absorb anything going wrong felt naive. That was the part
Yes.
that I thought was bad.
Yeah,
So, yeah.
and now we get to see what happens when you have a timetable that can't absorb anything, and now you've had several things happen along your path of development for that. And to kind of speak a little bit towards Blue Origin and SpaceX being able to be riskier than NASA, NASA is beholden to Congress and the taxpayer. So for NASA, you have to do it right the first time. Messing things up gets you in trouble. While for
Mhm.
SpaceX and Blue Origin, you are contracted to do these things, but at the same time, SpaceX is got Elon Musk behind it. Blue Origin has got Jeff Bezos behind it. These are two individuals with deep pockets that are willing to throw infinite money at the problem. So
Yeah.
for them, a blown up rocket is no big deal.
Yeah,
It's
well,
just it's a
Bezos threw
drop in
money
the
at
bucket.
Bezos threw money at the Expanse, and now he's
Yes,
throwing money at Blue Origin.
I
So
am
yeah,
glad he
yeah.
put money into the expanse. I mean, I'm a huge Trekkie. This went beyond my love for Star Trek. The Expanse is an incredible series.
yeah, I,
Hmm.
I agree with you. That's why I brought it up. Did you know they once came and visited Griffith Observatory up there? I didn't get to meet the cast that was there, but Laura Danley, our previous curator, did, and she was rather thrilled by it. Although I think her favorite actor wasn't there, and I was just like, oh, come on. It was very funny. Well, Jared, I know I want to share something else here, and my share button is behind my camera. I've put the camera in the middle of my screen, everybody. So there it is. I don't think we need sound, but whatever. We'll still share it. What I don't know if folks have heard about this, but SpaceX has petitioned, what is it, the FCC? Who is it that we petition to
Hmm.
launch 1 million new satellites to do. Now, this is a data center he wants to do in space. Everybody
Yes.
knows about these data centers that
Yes.
are popping up all over rural America in backyards of people. That people claim they're
Yes.
eating up the water, which I don't know how true all that is because there's lies on both sides of everything on this. But the big problem is nobody's looked into it and really predicted what are the outcomes of these data centers being on the ground. And now Elon wants to launch them into space with 1 million satellites. Now, this was it was a problem when he wanted to do 10,000 or 40,000 or 60,000. But 1 million, this is a simulation here. I'm going to click on it that is showing what the sky would look like. On the right-hand side, this is showing kind of what it looks like now with the tens of thousands of satellites, what you would see. On the left-hand side is what you would see in the night sky if there were 1 million of them up there. So the sky would literally they would greatly outnumber the stars. Right
Yeah.
now, prediction is like one satellite for every 15 stars or something like that. It's not good. But, yeah, it's crazy. This is insane what they're saying. Was this real? Is he really talking about doing this, Jared? What is it, a stunt? Like,
So as far as we could tell, it is real. It does look like what Elon is trying to do is basically make SpaceX an everything company, literally going from chip development to obviously satellite manufacturing by building their own Starlink spacecraft in-house, to developing a launcher, the Starship Super Heavy, to launch these vehicles into space and then eventually deliver them, which I believe they're supposed to be going to a high Earth orbit in order to, in his words, compensate for the fact that there's going to be so many in space. And it's, there's a lot of challenges in physics that are going to have to be overcome just to even think about putting one data center in space, let alone a million data centers into
Well,
space.
what does
Uh,
this do to our atmosphere as that many rockets are being launched as well? It's just
That's a great question because a lot of times the amount of energy that a rocket is putting out, the amount of pollution that a rocket is putting out is negligible. Tim Dodd, the everyday astronaut, actually did a really great video about uh, rockets and launching them and just like how much pollution, how much carbon dioxide do you make, how much nitrous oxides do you make, all these other nasty things that we really don't like to have in our atmosphere. And compared to something like air travel, it was negligible. Even comparing it to something like the amount of uh, carbon output from the fashion industry is negligible, things like that. But for launching a million, this could be a lot in order to pull that off. We're talking, the SpaceX has always said with their Starship Super Heavy that they want to make it essentially like an aircraft in terms of operational ability. And if you get on an airplane to go somewhere, especially towards the end of the day, you might be that sixth, seventh, or eighth flight of the day for that airplane. So to get that number of rockets flying is just going to be absolutely outrageous. And I feel like there is something that it just doesn't seem like anybody's thinking about the consequences of
yeah,
what that is going to do in terms of consumption of fuels here on the ground. So obviously you have to have power in order to generate your fuels. Uh, like if you're going to work with methane, you got to have a factory that
yeah,
allows you to make a tremendous amount of methane to fuel up your rockets. Same with getting your oxygen for your oxidizer, and it's very energy intensive in order to do that. And in addition to that, I feel like the upper atmosphere as well is going to take a hell of a hit with these kinds of things. Now, I haven't. I know there are groups out there that have done studies of this. I can't think of any of the papers off the top of my head, but it is something that people are looking into.
yeah.
But I feel like, especially with data centers in space, there are so many problems with physics. Like, how do you take this tremendous amount of heat and reject it from your data center in space? It's very difficult
Yeah.
to do that.
I'm
You
wondering
don't
if
have a medium,
well, yeah, I'm
right?
wondering if Elon was
So,
thinking space is cold, and it's like, well, actually not. You're in thermal equilibrium with the solar radiation at that distance, and one
yeah,
side is going to heat
Ooh.
up, the backside's going to cool down, but even then, you're only radiating away your energy, which is not that efficient.
yeah,
Radiation's
no,
not a good way to cool down.
no. I've seen. So, from what I understand, the design for the data center satellites is something like several school buses in size for where your server rack is going to be for everything. And then you're going to have a radiator attached to it, but the radiator is going to be something like a double digit number of square kilometers in size for one satellite. That's a big, these are structures that are bigger than anything we've tried to deploy yet. So some of the biggest structures we've deployed in space are rumored to have been on spy satellites from the National Reconnaissance Office, and we're
Yeah,
talking things maybe like an American football field in size, roughly. Um, you know, at least for declassified or non-classified things, the James Webb Space Telescope is about one of the largest deployable objects we've sent into space, and that's
yeah,
that's what, a school bus, something like that in terms of size. So to do like a double digit square kilometer radiator, that's gigantic. That's massive. That's
yeah,
gigantic.
and
Holy moly.
it's gonna ruin the night sky, and
Yeah.
it'll also make
Yes.
planning getting off of Earth more difficult. I mean, how do you, if
Yes.
you want to go launch to Mars or go launch even to the moon, you're going to have to go to a lot of work.
Yeah, I mean,
Speaking,
Yes.
right
yeah,
now we don't necessarily worry too much about it. We look into it when we're launching things, but usually, like the sizes of things, they end up being in terms of like size of an object at orbital velocity relating to the amount of time that you like the window of time you have where a collision can occur. We're usually talking like hundredths to maybe even thousandths of a second. Something at a double digit number of square kilometers in size, we're starting to get into the 1 to 2 to 3 whole seconds of time
hmm
where you will have this like spread window of you'll run into this object on your way out, and that's like not that's very much less than ideal.
yeah, it's
um
not good. And also, missions don't always go to plan. So emergencies can
no.
happen. Engines don't boost like they're meant to. You're on a different trajectory, and all of a sudden,
Yeah.
oops, we're not going through that window we thought we were. It
Yep.
it just feels bad. It feels like a
Yeah.
bad plan.
There are also two other things that I was thinking about with that. High Earth orbit is not conducive for deorbiting dead vehicles. So, right? So
Yeah, good
things up
point.
in geosynchronous orbit get put into graveyard orbits because their the orbit time at that altitude, at those orbital altitudes, is measured in hundreds of thousands of years. At that point, it's basically
Mhm.
the gravity of the Earth, the Moon, and the Sun interacting with each other to eventually fling it down. It's not like a low Earth orbit where Starlink, it will run into, if Starlink dies, it admittedly does run into atmosphere and it re-enters within a couple of months, which is that is better than nothing. So, but at those high altitudes, there is nothing there. So if you like do lose your satellite, it is now careening around in orbit, and everybody's got to worry about it. The second thing too that I heard in the presentation that Elon gave about the AI data centers is that they're just going to use regular computer chips for it. They're not going to use radiation hardened computer chips for that. And that's just asking for cosmic rays and solar storms to just zap your constellation, right? I mean, there was a couple years ago
Uh,
when SpaceX, I don't want to necessarily say ignored a solar storm warning, but definitely didn't take heed to it, and they launched a set of Starlink satellites, and they were fried instantly after
mhm.
they were on orbit, and that like a whole batch of Starlinks were done. So
Yeah, he doesn't
yeah,
listen to warnings very well at all, and
no,
unfortunately.
Mm.
no,
Uh,
unfortunately.
Jared, I'm curious. So, are these going to be, you say, in high Earth orbit, or they're going to, no, they're going to be at some Lagrange points? Because I was reading this article too. Is it one going to be at like L1 or L2?
Yeah, so nobody's really been able to get Elon to give a straight answer on
Ah,
Mm.
many things, which is also like not unusual, unfortunately. But a lot of us have heard high Earth orbit because they want the low latency. But we've also heard that they might want to put it at a Lagrange point because you could just set it and forget it in that area in terms of like how much
But
propellant you have to
But even that
carry and
a
just
million of them there, they're on
yeah,
orbits at that place, and it's not
they
an
are.
infinitely large area. I don't know. This is all
Yeah,
sad.
you
This is
literally
all
orbit.
bad.
If you put something at L1 and it does this, it completes an orbit around L1 twice a year. So it's not like it's you put it there and it stays still. It's
right.
still in an orbit. So
Yeah.
Wow.
Wow. Wow. Well, and
Mm.
maybe
yeah,
L2 would be better than even high Earth orbit because at least then they'd be kind of all off in one direction. Because it's really going to ruin the night sky. This is something that, the night sky is an inspiring thing. People
hmm
Yes.
very few people these days, or fewer, get to a location where you could see the Milky Way. But that's part of how I got here as an astronomer, how I became an astronomer, was camping with my parents and family and having a small telescope and seeing the rare satellite moving across the sky and going, oh my goodness, what is that? And I think
yeah,
seeing, we used to call it the three-horned devil. It was the triple satellite, and it was a military one. It was a surveillance satellite of some sort. I think they
Mm.
were probably doing interferometry, is my guess now that I'm thinking about it, because it needs
yeah,
really
mm,
precise positioning.
yeah.
And
We
I think
now
it was,
know that those are naval surveillance satellites. There's signals
oh,
intelligence and things
Oh,
like that. So yeah,
okay. Fascinating.
so
Very
mhm.
cool. Anyway, but we can experience that on the ground, but when people go to space, there's a whole other thing that happens. And we hadn't sent people into, well, at least far from the Earth in a long time. And this effect that I want to talk about. But first, I want to play some of the interviews of the Artemis 2 crew. But they were the first astronauts to get a good view of the Earth being small out their window. When you go into low Earth orbit, you still see the Earth, but you don't get a view of all of it all at once. You're seeing it passing under you. So it's a little bit different. And I wanted to play some of what was going on here. And here's Reed Wiseman and what he was saying about it. And I'm gonna share my screen here again. Gotta dodge back and forth and find the right button. And here it is. Okay.
Knows what the families went through, man. This was not easy. 200,000 plus miles away from home. Like before you launch, it feels like it's the greatest dream on earth. And when you're out there, you just want to get back to your families and your friends. It's a special thing to be a human, and it's a special thing to be on planet Earth. Thank you.
I want to get back there. Saw Earth and yeah. I hear some.
Wait, now I got to make a joke. The only person who can follow that up is Victor Glover, so let's go.
And now we're ready for questions. I'm gonna keep it brief because I'm afraid to start talking. I have not processed what we just did, and I'm afraid to start even trying. When this started on April 3rd, I wanted to thank God in public, and I want to thank God again, because even bigger than my challenge trying to describe what we went through, the gratitude of seeing what we saw, doing what we did, and being with who I was with, it's too big to just be in one body. And I wanted to thank our families for everything that he just said. So great words, great words, great words. I love you, but not just those 5 beautiful cocoa skin ladies right there. All of you. And I wanted to thank our leadership. And it's changed since we were here in April of 2023. But the qualities haven't. And we are fortunate to be in this agency at this time together. And so I'm going to sit down. Thank you also to our air operations.
Okay, he's got a lot of people to thank, which is great, of course. But
yes.
I want to jump ahead to Christina Cook and some words she had to say, and we'll play through a lot of this.
Knocking on my door in crew quarters and whispering, "Christina, we're go for launch. Get up." And it ended last night when my nurse on the ship put me to bed and said, "Ma'am, can I get a hug?" So a lot has happened since then, but or between those two moments, but the start and the end were human moments here on Earth. So several years ago, I was giving a speech and I was doing my usual talk about crew and crewmates and teamwork, and someone asked the question, what makes a crew? What is different about a crew than a team? And I was like, I got this. Opened my mouth confidently to tell them everything I knew about being a crewmate. And everything that came out of my mouth was completely without value. I was like, yeah, crews, they're in space, and they work together, but they eat together too. So, they're a crew. Right. And boats have crews. You're a crew if you're on a boat. Helps if you have a paddle. That'll be good. That'll make you a crew. But the last 10 days, I've gotten a little bit of a better answer on that question. A crew is people, or, a group that is in it all the time, no matter what, that is stroking together every minute with the same purpose, that is willing to sacrifice silently for each other, that gives grace, that holds accountable. A crew has the same cares and the same needs, and a crew is inescapably, beautifully, dutifully linked. So when we saw Tiny Earth, people asked our crew what impressions we had. And honestly, what struck me wasn't necessarily just Earth, it was all the blackness around it. Earth was just this lifeboat hanging undisturbingly in the universe. Uh-oh. So I may have not learned, I know I haven't learned everything that this journey has yet to teach me. But there's one new thing I know, and that is, planet Earth, you are a crew. Yeah. Thank you.
So yeah, it made me tear up.
Yes,
Yeah.
we're crew planet Earth.
Yeah,
Yes.
we're from planet Earth. So Jared, is this common? Is this what happens to astronauts when they see the Earth tiny out there in space? Do they come back changed? Because that's not the same crew they were before they launched.
Yeah, almost the idea of the person who left Earth is not the same person who returned to the Earth. It really sounds like some sort of like science fiction horror thriller film, but actually it is something that is a well documented psychological effect that occurs in astronauts, and it's something called the overview effect. And the overview effect is often cited as a overwhelming emotional and psychological response to seeing the earth from above from those perspectives. And for many astronauts, they go through the overview effect. They talk about, all of a sudden I didn't see borders anymore. I just saw the planet. I just saw us. Here we are in the inky darkness of the universe, this lifeboat, like Christina said there, of the Earth. So the overview effect is something that is real, and it is experienced by astronauts. Not all astronauts have experienced the overview effect. There are astronauts who go up and kind of feel the same way about the Earth as they did when they come back, but it seems that a vast majority of the astronauts that go to space come back changed. And it also doesn't have to be necessarily a flight into orbit. With Blue Origin's New Shepard vehicle and Virgin Galactic's Spaceship Two vehicle, they've been launching people on suborbital flights. They go up to space, go up, get to space, come right back down. Like a 10 to 15 minute long flight total. There are also the people flying on those who are also receiving the overview effect when they do that. And
Okay.
And I think a really great example of that was William Shatner.
Yes.
From Star Trek, flew on one of the Blue Origin New Shepard flights. He was invited to fly on it. And everybody, when they are all getting out of the capsule after it's landed, everybody's all super happy and everything. And William Shatner is just like, he's almost like shell shocked in awe of what he saw while he was up in space on his several, like, he was only looking out the window for about 4 to 5 minutes, and that profoundly changed him as a person. And he has
Mm.
talked about it in an interview, saying that it's actually made him feel worse about how we are treating the earth and polluting the earth and doing things to the earth.
Mm.
So sometimes, most of the time, it is a positive effect. Sometimes it can give a negative effect like that. But for most astronauts and most people that experience
Yeah.
it, it's a profoundly positive, a life-changing effect. And there's even differences in the overview effect as well. The Apollo astronauts had significantly more powerful experiences with the overview effect than shuttle and space station era astronauts
Yeah.
have, because
Well,
for
Wow.
them, the Earth was so much smaller in their
so much smaller.
perspective.
And we
So
kind of
yeah,
saw that with the Artemis 2 astronauts, that for
yes,
them they experienced it in that same way. This
yes,
brings to mind that we ought to, at least I think, perhaps we should require the majority of our leaders to take a trip into
Wow.
space and come back, so that they see the Earth as it really is, rather than
yeah.
as this perceived notion they have of what Earth is. Um, yeah,
Yeah, it would
maybe.
definitely be helpful, to say the least.
Indeed.
At least in the history of NASA, there have been only 3 people involved in the United States government that have actually, or excuse me, 4 people involved in the United States government that have actually gone to space. Jake Garn and Bill Nelson, both senators from the 70s up until the 2010s, at least in the case of Bill Nelson. And then Bill Nelson was NASA administrator under the Biden administration. Richard Shirley was an astronaut who was a NASA administrator in the early 90s, and he had flown a shuttle mission, and he was a commander of one in the 80s, and he became administrator to fill in post Challenger and basically steer NASA back on its course. And also now the current NASA administrator, Jared Isaacman, is also an astronaut in his own right. And he's done 2 flights, both flights that he paid for through SpaceX to do. So having people who have those experiences in those kinds of places,
Yeah,
uh,
yeah, and
yeah, we kind of
John
we kind of need
Glenn.
more of that.
Yeah, John Glenn was also a senator, so uh
Yes, yes, him
he
too. So
was so now I firmly believe we need to be somehow inspiring people on the earth too. Okay, the overview effect, that's too much to ask. You need to go to space. We can't take the majority of people into space to get to open their eyes. But people don't understand basic science. They don't understand the basics of Earth.
mhm.
They don't understand how scientists actually do their work. They have these notions that we stand around until this idea strikes us and then we go, oh, eureka, that's the answer, versus hours and hours of hard work in the lab and
Oh
testing things
man,
and slow steps to get to the final answer. So in order to make these changes we need to make and have people educated enough to vote on things correctly and fund things correctly and understand how things
Yes.
are working in Congress, Jameeka, who's here today, runs a program called Shadow the Scientist, and I'm going to share my screen here again. I
Oh,
love just like leaning around briefly. And there it is, perfect. So Shadow the Scientist is based at University of California, Santa Cruz, which is where I got my PhD. But Jameeka, you are the program manager of this, and it's an outreach from a STEAM program that's designed to create equity in science and in STEAM for students. And it does this by linking scientists to students directly through Zoom. Now, we've talked about this before on All Space Considered, and we've talked about it in other places. But I just wanted to point out, folks can go here, they can read about it, they can see the video. Tune in the old All Space Considered. You were on just a couple of months ago. I think it was
yes.
April. And
Yes.
you can hear that part of it. So I don't want to rehash that too much. But I just wanted to let folks know that you've gone to the AAS meeting, and in 2024 you presented a paper about it. And
Yes.
this is having an impact, and people can go to the YouTube page. So when you're done watching this show, go check Shadow the Scientist YouTube page, and you can go check out various things, the International Gemini Observatory, the Keck Observatory, the Subaru telescope. So all the way down the line. So So, folks, Jameeka, you saw this possible, but how did you get here? And where, first of all, where are you? What is this beautiful background you have behind you? So, Jameeka, where are you right now? That's gorgeous.
Well, thank you. Thank you so much, David. Well, I am so excited to be here and to actually share this view with you all. I live on the Big Island of Hawaii, on the east side in Hilo. So I am here actually at a beautiful park in town called Queen Liliuokalani Park. And this park is, of course, named after the last sovereign monarch of Hawaii before
Hmm.
the overthrow. And so Queen Liliuokalani ruled from roughly January of 1891 until January of 1893. And so this park is one of many places around the island named in her honor. And yes, and we are 3 hours behind Pacific time, so it's just early evening here.
Yeah. So, well, how did you end up in Hawaii? Where did you start your life? I don't think it was in Hawaii.
It was not, David. I am originally from Memphis, Tennessee. I am a Southern girl. Um, how did I get here, though? Well, it really started with enjoying the night sky with my grandmother, Verna Jean Flemings, and she was always my biggest champion. And you were mentioning watching satellites move across the sky. That was one of the first things we did was spotting satellites. And
Mm.
then later we started looking for, of course, constellations and then star clusters. And I was hooked. That combined with my love, complete infatuation with Star Trek and Lost in Space, those shows that were coming on in syndication in the 90s from 70s or whenever they came out in the 60s. Watching those in syndication along with enjoying the night skies with my grandmother, I was hooked. I was hooked to astronomy right then. Growing up, I was so grateful to have my mom, Liz. She would any kind of astronomy related events or science events I wanted to do. She always encouraged me
Mm.
to do so. Got a telescope. So did my grandmother. Telescopes we shared looking at the night sky. And it was just fascinating. That wonder that would potentially be lost with millions of satellites and other things in the night sky, crowding out the natural beauty that belongs to all of us. That wonder is what inspired me. And you are absolutely right that it would be a huge treasure lost if changes aren't made.
Yeah, yeah, I worry about that because there are fewer and fewer opportunities to see the night sky like that.
That's right.
What city were you in growing up in Tennessee? You were in Nashville, you said?
I was in Memphis,
Memphis,
actually
Tennessee.
in Memphis,
So now how
Tennessee.
bright was
Yes.
Memphis in the 90s? What was the night sky like?
It was beautifully dark in my grandmother's, my grandparents' home. It was beautifully dark. I could see the Pleiades, known as
Okay.
Makali'i, here in Hawaii. I could see the Pleiades very clearly. It's one of the first open clusters that I observed with my grandmother. I could see the Milky Way. It
Wow,
was
okay.
Yeah, it was, but they lived very close to the Mississippi border, so well away from kind of the main parts of the city.
Hmm. Okay. Now the Pleiades folks that want to go look for it, it looks like a little mini Big Dipper. In fact, a lot of people think it's the Big Dipper when it's not, but it looks like a little mini one. It's known as
Mhm.
Subaru to the Japanese. So those of
Sure
you that are
is.
driving a Subaru, you're driving a Pleiades car. Little did you know.
Yes,
Yeah.
and in fact, you can see the stars on the back of the Subaru. The emblem, I think, has 5 or 6 stars
Yeah.
representing that. Mhm.
Yes.
Yeah, it does. And there's even a telescope Subaru that is on Mauna Kea right
Which
there with you.
is
There's an 8 meter
right
telescope.
here. Yeah,
Yeah.
that's right. I'm looking in the direction towards Mauna Kea right now. We have the evening inversion, so we can't actually see it, but it is
Hmm.
directly over there if we didn't have that inversion layer blocking our view.
Yeah. Now Mauna Kea is probably poking out above that, and they're going to be observing tonight in all likelihood. That's how usually is the times I've been there. Now
That's right.
you are connected to how many telescopes up on the mountain at this point?
Oh my goodness. We work with, we have incredible collaborations with all of the large meter class telescopes. So you mentioned the International Gemini Observatory, the Keck Observatories, Subaru Telescope, Canada Francois Telescope, the NASA Infrared Telescope Facility, and over on Maui, we also collaborate with an astronomer, J.D. Armstrong, who works with Las Cumbres Observatory. That's actually a collection of robotic telescopes, but one of those are actually located on Maui at Haleakala, and that's the Fox North Telescope. So 6.
Okay. Okay, this is just my own curiosity. Have you connected to any of the volcano observatory folks? Do you have any scientists there? Because Kilauea has been going crazy.
Kilauea just erupted again a few days ago. In fact, actually, it may have been earlier this week. Yes. I love Kilauea. I love living in a place that is so active in so many ways. Not only is, of course, Kilauea one of the most active volcanoes on the planet, and we just had episode number 48. It's been
48?
going.
Is it
Yes.
still about every 2 weeks that it's happening? Is there a periodicity to this? Because I need to buy a plane ticket to see this. And
Come on over, David. Come on over, Jared. Yes, it's about every few weeks. And this has been since what, 2025 that this has been going on, maybe 2024. I'm not sure. It was Christmas though. And I had actually taken a friend out to see the eruption. It was her first time there. And that's when this periodicity of 2 weeks, 3 weeks started. And it's been going ever since. So you can depend on Pele. You can depend on Pele.
exactly. But
Yes.
but do you have any volcanologists that folks can watch?
Yes, we actually had one incredible session with geologists at the Hawaii Volcano Observatory. And so definitely you can find that on our YouTube channel. We definitely had plans to continue that collaboration, but funding challenges happened last year, and so we've had to put that on pause. But the motivation on my end is there, and the desire on their end is still there. And so hopefully soon we can have them back on the show, because the work that they do is absolutely incredible. But yeah, check that out. We were actually, for that session, focused on petrology and looking at new lava samples that they had recently gotten from Kilauea in the episode, and how they actually
Very
how they actually, what research they do and what they're trying to get from their observations and the experiments that they conduct on the lava. It's incredible, Jared and David. And I have to say, I love science. So to be in the position where I get to work with scientists from various professions, from, engineering, ecology, volcanology, astronomy, heliophysics, it's just all absolutely incredible. Never thought I could do something
yeah.
as amazing as this.
Well, yeah. How did you go to Hawaii to do astronomy, or were you doing it elsewhere and you just found your way there? Like, how did you make this happen? Because you certainly are making things happen.
I'm so grateful for all of the opportunities that I've had in my life. My mother always encouraged me to pursue my dreams. My family always encouraged me to pursue my dreams, but especially my mom, and my brother Michael, my grandmother, and just everyone. So when I lived in Memphis, as I said, I loved astronomy. I joined the Memphis Astronomical Society, and that's kind of where I
Very
started.
cool.
And then I volunteered at the Rainwater Observatory in Mississippi. Did a lot of work there, and really started to learn the skills from all of the people running not only the Memphis Astronomical Society, but the Rainwater Observatory. They took the time to share their knowledge with me and to make sure that any questions I had were answered, and gave me ample time for self-discovery and learning on my own. Um,
Wow.
that's where it started. And when I went to university, University of Memphis, a great college, they unfortunately didn't have an astronomy program. So I did something else that I love, which is studying languages, and then later a master's degree in teaching there. Languages bring people together, right, Jared, David?
Yeah.
Brings
Yeah.
people together,
Yeah.
and so do other things too. But science is something that can bring people together too, and that's what I'm continuing to do. That spirit of unifying people has never left me. Um, my mother has reminded me that I wanted to be a journalist. I also wanted to be a diplomat. So she has supported me in being part of youth legislature, Model United Nation, mock trial. I did all of those things, and that was still something that I didn't think I could go into, but still working together for a common goal
Yeah.
was the common denominator. And now, as the program manager for Shadow the Scientist, I get to do that with science. I'm like a science ambassador.
Well, you really are. And you bring this not just to students, you bring this to anybody that wants to join. People can sign up, you can send in the
Yes,
information, and then they'll be invited to the sessions that are open to the general public. Students have separate sessions, they're closed. That way the public isn't, causing mayhem, and the students feel comfortable to ask their questions and things.
that's
But I
right.
love that it's open to anybody that wants to watch. And you have people
It
that have been
is.
attending session after session after session. I have folks I've
I
talked to
do.
that simply love this. So this is one of the reasons why I'm thrilled to bring you on the program tonight to talk a little bit about you, how you got here, and what you're doing to bring all this here, and how we can open people's eyes and stop things like those million satellites. That's just craziness that's going to happen. And if we can have people
Hmm.
tune in to things like Shadow the Scientist, see that astronomers are observing from the ground, there's this stupid notion of, well, why don't you just observe from space? You can't put a 30-meter telescope in space. I'm sorry,
That's
people.
right.
That's what they're building. There's several of them being built now. There's
Hmm.
TMT that's under construction on Mauna Kea. Has hit some problems, but hopefully it'll go forward.
Well,
Fingers
well,
crossed. It'll be. Oh, you
let
do
me
have an
pause
update for
there.
us?
Yes, so there's no construction of TMT happening on Mauna Kea. Let me just
No,
be
what?
very clear on that point.
Yeah, oh, yeah, that's true. The construction hasn't happened, but the planning, I guess, is what they were doing, and they haven't cleared all the hurdles, and
That's right.
Yeah.
the things are stuck. So it's a little unfortunate. They've been talking about moving to another site. I'm not sure they will or whatnot. It would be a little bit of a tragedy, as it's one of the best sites to observe from on Earth. The Europeans are building the extremely large telescope, the
Hmm.
EGLT. That's going to be what, like almost a 40-meter or something like that. It's a
Pretty
mind-blowingly
close.
large.
Yeah.
Um,
Almost there.
yeah, and then there's the GMT, the Giant Magellan Telescope, that's actually
Yes.
five 8-meter mirrors that when you add them all up together, it ends up being a collecting area over 25 square like the equivalent size of a 25-meter dish. Now that falls it right in the 30-meter class, because the 30-meter class, you lose certain things due to the center and the structure. So basically the same
Hmm.
collecting area. And that one might get finished first, actually, which is, they're going with known technology. We know how to build an 8-meter mirror.
That's
Um,
right.
but these are going to be opening up frontiers and doing work that's really going to be paired with the things Webb is looking at right now and unlocking the secrets. And that's what I get bothered by. A million satellites crisscrossing the skies is going to pose a really large problem for observations. So,
Absolutely, David. It really is. And in fact, in one of our previous sessions, we've had questions on that. Have the increased number of satellites had any effect on their research? And I believe this was a session with your colleague Laura May Abron
yeah.
and
And
Bryce
Bryce, yeah.
Boland. Yes, and I believe Laura May answered the question, and then also Bryce. And Bryce said that and Bryce uses space telescopes, used telescopes on Mauna Kea and just around the world, and said up to this point there hadn't been really any noticeable effects. A few times, but it was not a huge impact. Though I can imagine that that's going to start to increase. Certainly, with 1 million satellites, that's just going to be incredible.
Yeah.
And so you were asking, what can we do to perhaps change the trajectory? And what I think we should do is what we have already been doing, which was sharing the good news about the beauty of the night sky and actually getting people out there. So yes, Shadow the Scientist certainly does that in one way, connecting everyone, students, the general population, general public, to scientists, astronomers here, as they're conducting research live and in real time. So that's certainly one way. You can see how if they did not have dark skies, how that would impact what they're getting back, the images, and then the spectra in particular. And we can already see how cosmic rays just are all over the spectra
Yeah.
with certain kinds of instruments. The other thing, though, is actually having people outside under the night sky, David,
Yeah.
that makes a difference. And as you said, there's many people now who've never even seen the Milky Way because where they live is too light polluted. So taking people out to dark sky places. So protecting dark sky areas, something that I'm grateful is being done, because that is part of our heritage as humans to have dark skies, and then to see the wonders that we can connect to with our eyes, with binoculars and telescopes. That beauty that has connected all humans throughout our history, that is something that we are at the point of being able to lose. Um, and
Yeah.
that connection to our ancestors and how they connected to the night sky and how that impacted the development of their societies, that's something that I personally want to help us to preserve. So in addition to Shadow the Scientist and my own personal work, and even once a month on Mauna Kea at the Visitor Information Station, we will take the live session, we'll do it there. And if we have time, we do stargazing. The amazing staff at the visitor station, they'll set up telescopes sometimes on the weekends, not every night anymore, but on the weekends, and you can sign up for those free stargazing sessions. And sometimes I do it after a session as well. And to just hear the oohs and the ahs and the wows, that is how you start to
That's
change the tide
Yeah.
of millions of satellites going up, because that person, that family now will say, oh no, but if we don't have the night sky, what are we losing? Because they've been
yeah.
under a dark sky. Now they know from their own experience what there is to lose, in addition to
So
all of the research opportunities.
I think we need a name for this. Maybe we should call it the underview effect. Instead of being the
Oh,
overview, it's the looking up. But
that's
I
right.
think you're right. I do think you're right. It's a combination of all of this. The exposure to science gets people comfortable with scientists, lets them understand what's happening. Seeing the night sky brings the awe and wonder. And I want people excited about rocketry. I like rockets. I always
Yeah,
have. I like exploration.
me
And
too.
launching 1 million data centers into orbit is not exploration. That's not what
Mm-mm.
we should be doing
It's
with that
not.
hardware. We could do
No.
so much more.
Yes, we could.
I personally want to see people on Mars. I agree with Elon in that goal. A lot of people don't. I don't like the way he's necessarily going about it, but I'd love to see boots on Mars. I think people can do
Okay.
exploration that robots cannot do. But if you're going to
Yes.
launch a
Yeah.
million data centers, well, let's launch 500,000 robot explorers. Let's go explore the whole solar system.
Uh,
Let's go to all the planets. There are so many moons that are unexplored. Folks, go look at
There
pictures
are.
of Triton. Have you guys seen Triton?
Oh,
I love
It's
yes.
Triton.
Yes.
yeah,
Every
Yes.
time I'm like, I want my Triton hopper already. Like I want
yeah.
my mission to Triton
I mean,
already. Like I want
I
that thing boing, go somewhere else and see
mean,
see another, geyser in the
another geyser
surface,
going off. Yeah, exactly. There's
Yeah.
geysers on
Incredible.
this frozen moon. It's crazy. The universe is an amazing place, and we
Oh,
can explore it
yes.
from here on Earth, but we need to preserve it. And
Yes.
thank you to both of you for tonight. It's been a lot of fun chatting about all of this, and um and about what's going on in space. And I hope folks tune in to some Shadow the Scientist, Jameeka, and I'll take you up on coming to see you out in Hawaii. I'm going to come out there and see the volcano, come by and see what you're doing. You can introduce me to some of the folks at the observatories there. We can,
You got
maybe
it.
we can have a good time out there. It would be really great. And Jared, I'll see you up at All Space Considered soon. Folks, I
Yes.
mean, it's my other job. I'm not at my my city job right now, but I'm excited about what we're doing this month. We're coming live
Yes.
from the Pasadena Convention Center. It'll be recorded live. It'll be tape delayed, let's put it that way. But we're recording it on Wednesday, 2 weeks from today. 2 weeks from
Yes.
today
Yep.
at 2:15 p.m. It's going to be crazy. Jameeka, are you
I'm
going to be there?
excited.
Yes, are you talking about the American Astronomical Society's
Meeting
summer
in
meeting?
Pasadena, yeah.
Absolutely. I will be there. And in fact, I was planning on attending All Space Considered. I didn't realize you were going to be hosting not at the Griffith
Yeah,
Observatory.
we won't be at Griffith on
Oh,
Thursday. We're going to be live at 2:15 p.m. on Wednesday. Now, the public, I don't think is
Wednesday.
invited, but so those of you watching this, don't just show up at the convention center, or if you do, play it off legit. Okay, you have to like keep it cool, and then they want
Yeah.
I'm just
But
going to
great. Well,
look.
we will see you there, Jameeka. We'll have to get together,
Yes.
and yeah, it'll
Absolutely.
be great to see you. Well,
Oh my
thank you
gosh.
both.
Yes.
Yeah, thank you, everybody, and thank you all for tuning in. And we'll see you next month at some point. And I don't know who my next guests are going to be. I've got some feelers out, and we'll have some more conversation about space, about science, about Earth, and how to inspire people to change the world, because we need to. So,
Yes,
anyway,
we
I hope
do.
everybody. Yep, hope everybody has a great night, and thanks, everyone. We'll see you next time.
Thank you, David. Thank you, Jared. Aloha.
Okay, it ended. We got that in perfect.